I'm Sun Wu from Franz Inc. Today I'm going to share with you some of our experience in smart manufacturing. Smart manufacturing is Industry 4.0. Next slide. There are three key components for Industry 4.0. The first one is all these sensors, Internet of Things everywhere. It measures the machinery and send out the copious data continuously. And you need some kind of machine learning technique, algorithm, to make sense of all this data. So is the machine running correctly? Is the machine running into a problem? When the machine running into a problem, you need the explicit and tacit knowledge to fix those problems. Next slide. We did one of these kind of project with Kyocera, a $14 billion company in Kyoto, Japan. They dominate the industry ceramic packaging business for IC chips, something like 70% or maybe even higher. Next slide, please. The industry ceramic manufacturing is a very complex process. For example, in this continuous furnace, there's a 20 baking chamber. Each chamber will have a different kind of chemical, air, different kind of temperature. And there's 90 sensor continuous measure the temperature, the humidity, the air pressure, the airflow, all this information send it out. Next slide. Unfortunately, when they see a problem, like a temperature hiccup like here, it's too late. The whole batch could have a problem. So the question is, can the machine learning help make sense of all this data? They got copious of data to prevent furnace breakdown before it actually happens. So you can, take some action. Next slide. So there's many different machine learning algorithms. Which one should we use? Is deep learning the best choice? That's a very popular hot one right now. Is this the best choice? Next slide. The answer is no. Deep learning is good for many things, facial recognition, voice recognition, but for this kind of industry sensor, it's not a good choice. The best choice is ISHM, stands for Inductive System Health Monitoring algorithm. It will give you a much better result to deal with this massive sensor data. Next slide. So we use ISHM to build a model, a learning model, and we'll plug in the furnace sensor data into it. In the case I just showed you that the problem happened, more than halfway through, but at the very beginning you already can see drifting. The data, the sensor send out data that it's not within the range, and so that will tell you something bad is going to happen. And so you can take some action or address the problem before it actually happens. Next slide. So what do you do when the ML model detect a problem? Most of this kind of knowledge is either in engineer's head or on menu or in other nodes. And this kind of knowledge is not computable. And the obvious example, Kyocera case, that when senior engineer is on site in one of those remote factory, the problem is much less. When they left, problem happen more often because all this knowledge is not computable, it's not shareable. Next slide. Next. And here is an example of the knowledge of one furnace. There's a 90 sensor, and so turn to 90 rows, a gigantic spreadsheet. And this is just partial display. It's very difficult to use by other people or for computer to make sense of it. Next slide. Next slide. So we need to turn the knowledge, all this knowledge, into a computable knowledge graph. You jump ahead. Please go back one slide. Hello, you are? Yeah. This is an example of two sensors. And it shows all the, when the sensor exceeds upper bound or lower bound, what's likely the problem? and for each different cause, what's the solution, how to solve this problem. And it's just for 2 sensors. And there's 90 sensors in the continuous furnace. And so it's a complex knowledge graph. But now the knowledge, it's computable. So computer can help. Next slide. And so you put this knowledge in the cloud, you can access anywhere. Kyocera has factory everywhere in Asia. They can access this information and allow the computer to help solve the problem. Next slide. So this is the vision. The vision of Kyocera basically is that you will have this machine learning module plug into the furnace sensor or this PLC sensor. And please click. Sorry, this is animation. Could you click? Yeah.
There you go.
Just go ahead. Anyway, enough. Stop. So when the furnace, when the machine learning module detect a problem, it will inform the engineer. The engineer will go to a knowledge base and to find out what is likely the cause and what's the solution to the problem. And also throughout this process, the machine learning module, whenever they detect a problem, they will record the problem within the knowledge base. And this knowledge base will be able to share with all the other furnaces globally. And when you accumulate enough historical information, then you can use machine learning again to identify what brand of furnace, what kind of furnace, batch furnace, continuous, different kind of continuous furnace, what kind of furnace is good for what kind of process. And this can be very useful information down the road. Next slide. So throughout this project, we find the biggest challenge is how to transcribe the operating knowledge in menus or spreadsheet into a knowledge graph. I mean, right now we do it in a manual process, and manual process is not scalable. And we like to automate this whole process. And also
Another 30 seconds.
This is the last slide. And we also want to incorporate the graph neural network to estimate the breakdown interval. Traditional machine learning may not be good at dealing with this graph type of event. And of course, we want to integrate the machine learning module with the knowledge automation, the knowledge base directly. And so the whole process will be connected. Ultimately, you want the knowledge base to send out a signal, send out instruction to the machine and actually make the adjustment automatically. So we're looking for some funding from the government, to do these kind of things. Thank you very much. That's my last slide. Any question?
Hi, this is Rose from Wesco International, and we're looking at the areas in knowledge. How are you compared to some of the competitors in the space?
I don't know much about the competitor space, but I do know that when we compete for the Kyocera project, Kyocera is such a famous company in Japan. And so many people, IBM Japan, Toshiba, everybody tried to get business with Kyocera. We beat them out because they all use deep learning algorithm. And we have a we have a special algorithm, as you mentioned, is this ISHM, and we actually make the prediction because they give us the test data set, and we actually make the prediction. And other people, many people probably will have the machine learning algorithm to even if they have ISHM, they can make the prediction. Not a lot of people have an ability to encapsulate the knowledge, and so that can do this knowledge automation. Many people look at the artificial intelligence, they look at the algorithm. How do you do facial recognition? But another big part of artificial intelligence is how do we use the knowledge to automate the process. And that's one area that I think we have a unique capability. We have uniqueness. Do I answer your question? Any more questions?
I'm going to just throw in one question there. Can you speak to a little bit of your traction so far as a company, whether grants or investments or additional customers in addition to Kyocera?
Our company main product is it's an AI development platform and also a knowledge database. It's a horizontal product. And Kyocera is one of the vertical applications that we work with as a consulting service. We work with Kyocera using our tool set. And we have been around for more than 30 years. We, for a while in the 80s or 90s, every AI developer used our platform to develop their application. So we've been around, we're totally self-funded. And we have been funded by DARPA a couple of times, more than 10 years ago, and basically developed to enhance our AI development platform. So we're looking for any government funding or anybody that who interested in this space, and we can partner together.
Thank you very much.